example from class today was x squared plus 6x plus 3 equals 0. In order to solve this by completing the square, we want to use these two terms to complete the square, and then 3 will be moved to the other side. So I have x squared plus 6x plus some value that will complete the square equals -3. My value that completes the square is going to be half of that b term squared. So half of 6 is 3, and 3 squared is 9. But I can't just add 9 to the equation because then that changes it. So I have to add 9 to the other side as well. Again, that is the addition property of equality. Property of equality. Now I'm going to rewrite my perfect square trinomial as a binomial squared equals -3 plus 9 is +6. And to solve for x, I'm going to take the square root of both sides of the equation. The square root of a quadratic cancels out, and we're left with the expression that was underneath the radical. So I have x plus 3 equals the positive and the negative square root of 6. Since 6 is not a perfect square, nor does it have perfect square factors, it cannot be simplified. So it's going to stay the square root of 6. I'm going to keep solving, so I'm going to subtract 3 from both sides of the equation. So I have x equals -3 plus the square root of 6 and -3 minus the square root of 6. And those are my two solutions. I can also solve the same equation, but instead of using the addition property of equality, we could use the additive identity, which is adding 0. X plus 0 equals x. Anything plus 0 equals itself. So let's see here. I'm going to have x squared plus 6x plus some value that will complete the square plus 3 equals 0. Since the value that completes the square is 9, because half of 6 is 3, and 3 squared is 9, if I add 9, I must also subtract 9. And that is adding in my 0. I can rewrite the perfect square trinomial, x squared plus 6x plus 9, as x plus half of that b term, 3 squared. And then I have -9 plus 3, which is -6. And all of that equals 0. And now I go about solving. So I'm going to add 6 to both sides of the equation. That's going to leave me with x plus 3 squared equals 6. I'm going to take the square root of both sides of the equation, canceling out that exponent and leaving me with just the expression that was underneath the radical, the positive and the negative version of the square root of 6. Since 6 is neither a perfect square, nor does it have any perfect square factors, it's going to remain a radical, the square root of 6. Continue solving by subtracting 3 from both sides of the equation, subtraction property of equality, and I have x equals -3 plus the square root of 6 and -3 minus the square root of 6. So my two solutions are these two numbers. X is the set of the two numbers that are -3 plus the square root of 6 and -3 minus the square root of 6. Since our solutions after solving were -3 plus the square root of 6 and -3 minus the square root of 6, I know some people may be wondering, what exactly does that mean? If I have -3 plus the square root of 6, that's approximately equal to -0.55051, as well as other digits behind the decimal, because non-perfect squares, when you take the square root of them, they give you non-terminating, non-repeating decimals. They're irrational. So if I take -3 minus that same square root of 6, I get -5.44949, as well as some other digits after that. So if I graph x squared plus 6x plus 3, I can see where the roots are. They're right here and here. And I can plot points along that graph, but not in the scratch pad. So I'm actually going to open a new document to do this. X squared plus 6x plus 3. And I'm going to put a couple of points on that. I want my point on the graph of F1, and I want it right there. And I want another point on the graph of F1, and I want it right there. So we can see that our roots are -5.45 and -0.551, which were the same values we got when we algebraically evaluated the -3 plus the square root of 6 and the -3 minus the square root of 6. So our solutions that we got by solving using the completing the square method, these are what we call exact. The decimal approximations would just be approximations, but we can list those as well. We can say -0.55051 and -5.44949. We can do that. We can list them exact, or we can list them as decimal approximations, but it depends on the instructions for the problem what you want to use. For the homework problems, you want to use the exact values.